this section, we're going to go over all of the different ways we can analyze, or I'm sorry, we can display categorical and quantitative data, as well as introduction to how to analyze it. So the first method we use for displaying data is a frequency table. This can be used for both categorical and quantitative data. They're useful because it's basically just keeping a tally of how many times the variable you are concerned with occurs. So this is the example we're going to use in class. It's also an example. I made another video showing how to actually construct all of the different graphs on your calculator. There's another video to that on the channel. I think it was the first video I actually made. So I apologize for the even worse quality on that video. But you see we have here a whole bunch of people that were interviewed for this survey. They gave their weight, their age, how long it takes them to drive to work, their highest level of school achieved. They put their gender, and then they recorded their income as of last year. All right, so what are the individuals in this data set? Well, the individuals are the people that were interviewed. There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different people interviewed. There are 1, 2, 3, 4, 5, 6 different variables at play here. So this is a very convenient tool for finding variables because we have 6 different variables that we can list, and they don't even have to be the same type of variable. Like we have categorical and we have quantitative. We have 1, 2, 3, 4 quantitative variables, and we have 1, 2 categorical variables. Like I said in previous video, sometimes you can have a categorical variable that is listed as a numerical value. Right now they have gender listed as a numerical value. These are all either a 1 or a 2. So technically, you can find the average between 1 and 2. It would be 1.5. So obviously, somewhere would be the average of these would be 2. Actually, yeah, it would be 1.5. However, it does not make sense to find the average gender of someone, right? If you have a whole bunch of people who identify as male, a whole bunch of people who identify as female, and who identify as something different, it does not make sense to find what the average gender of the people in that room are. So finding the average of this doesn't make very much sense. Therefore, we list this as a categorical variable. You could make the argument that the school completed could be listed as a quantitative variable, but you first would have to go through and assign a year value to each of these things, right? So you could have a 9 for 9th grade, 12 for a high school grad, 14 for associate degree. You'd have to have a little bit more information here for some college, maybe a 13, master's degree plus 4 plus, I think it's 2 extra years for a master's, so that would be 16, 18. So this would be like an 18, and so on. So you could do that and find the average number of years of school someone has had, but right now, the way this is listed, it does not make sense to find the average between a master's degree and an associate's degree or anything like that. So that's why this is considered a categorical variable. I also want to bring your attention to a couple of things. The travel time to work. If you are trying to find the average of something and you're given a 0 or an N and an NA in the same list, NA means that this does not apply to that person. So this person does not have a travel time to work. That is different from having a travel time of 0. So this person works from home. This person does not work. So when you're trying to find something like travel time to work, please do not make the mistake that substituting in a 0 for something that is NA is a good idea. It might be under certain circumstances, but you have to understand the context, right? So in this context, having a travel time of 0 means I don't have to travel to get to work. My work is either right next to where I live or I work from home. Having an NA means it's not applicable. I don't work. I don't have a travel time to work. 0 is a numerical value that you can average into other things. NA is not. So don't make that mistake. Now, for categorical variables, these are 3 of the main ways you'll see categorical variables displayed. We have a frequency table here. We have a pie chart. That's something that's used very often. And then we have a bar chart. So a bar chart is a bar graph. We've seen these hundreds of times. A couple of things to keep in mind. You notice that each of the categories that the variable, each of the categories that the variable has been split into is separate. There's no overlap. The bars are not touching for a categorical bar chart. For the pie chart, you have the same thing. All of these, since this is listed as a percent, all of these would add up to 100, and each category is presented here. You also have a frequency table. It lists the variable, the values for that variable, and then you can have it listed as either as a count, so how many times it occurs, or you can have it listed as a percent, what percentage of the total that occurs. Next, we have quantitative variables. We'll see these three primary ways. The first one is a dot plot. Of course, you'll see them listed as a frequency table as well, but didn't really have to list that again. We have a dot plot. So that is essentially you put a dot for every one occurrence, or maybe you change these or 5 occurrences or whatever you're doing. But basically, each dot represents an occurrence for that data point, right? You also have histograms. The biggest difference between histograms and bar charts, besides that they're categorical, is that you see here on the histogram, the bars are actually touching each other. There is no gap. There are no gaps in between. It is at one continuous flow of numbers. The only time you would have a gap is if there are no data points for that particular value. And then we have box plots, or a lot of times called box and whisker plots. What these do is they take a 5-number summary that we'll go over a little bit later, and they list those 5 numbers in a visually meaningful way. So you have your median value represented here, so that would be the middle. Then you have your first quartile and your third quartile on either side, so that half of the data point, so 50% of the data, is within this box. And then outside of the box, between the box and the whisker, you have the lower 25%, all the way until the minimum value. And then you have the upper 25% on this part. So this would be anything between the third quartile and the maximum. Now, when we're looking at quantitative graphs specifically, there's a certain way we would like to describe them. The acronym, I think that's what they're called, acronyms, that is easy to remember is you cuss about the graph, right? You have a CUSS. You first describe where the center is, where if there's anything unusual, you describe the shape, and you describe the spread. So first, where is the center of the graph? Well, if you imagine each of these dots is its own weight, and we're trying to balance this x-axis on a certain point, you would obviously you're not going to be precise. I mean, there are ways you can find the actual midpoint, which we'll get into later. But if we're trying to describe it, we would say, well, the midpoint would be right about here. That is, where is that? Right at about 60. I would say 65. If we know what the mean and the median are, then we can use those values. However, if we don't, we just have to go on. If there's anything unusual about the graph, so if there's any outliers, so if there's any dots that are just way outside, way far away from anybody else, we would describe those. If there's maybe it goes up, for example, in this histogram here, this goes up very early and then it has another peak, so maybe we would note that it has 2 peaks here. Like I said, if there's any outliers, there's anything weird going on, a lot of times anything unusual can, that might have already been described in your shape description, which comes next. So we describe the shape of the graph. Literally just do our best. It starts off very small, it gets much larger towards the middle, and then tapers off and gets small towards the end. There is a specific name for graphs that look similar to this, which we will learn later on, but for now, that. And then the spread. How spread out is this graph? So this graph goes from 50 to 80. So the minimum value is 50 inches. The maximum value is 80 inches. Now there is something that that we will learn how to calculate later called the variance and also the standard deviation. So if you have those values, it would be good to use those. However, if you don't know that, then just describing the range of the graph. Any measure you have to describe how spread out the graph is, be it range, standard deviation, or variance, if you have them, would be acceptable.